Okay, so I'm just going to open up this reservoir. So you see this is just a container, right? This is just a Perspex. There's a little rubber seal around the top and around the bottom. And then here, this is just a piece of foam. Yeah, so it's nothing, just a piece of like packing foam or something. But there's a small magnet right in the middle. And what happens is that if I turn it the right way around, then when the piston is down, the magnet in the disc is attracted to the metal of the piston. So if I raise the piston up, at some point that magnet disconnects. And so what's happening then is this pad is just going to go up and down. When the bottom plate is going to be our hot reservoir, and the top plate is going to be our cold reservoir. So when the foam pad is on the bottom, you can see we have the gas that's inside this container is then in thermal contact with the top plate, right? This foam pad is just blocking the gas from being able to get into contact with the hot plate. And then when the piston goes down and causes that disc to come up, now it blocks the top plate, right? The cold reservoir. So when the pad is down, the gas is going to cool down. And when the pad comes up, the gas is going to heat up. Yeah? Yeah, so it's just when the pad is up like that, the gas is only in contact with this plate. And when the pad goes down into here, then the gas is only in contact with the top plate. And the top one is going to be, the top plate is going to be the cold plate, the cold reservoir, and the bottom plate is going to be our hot reservoir. This is my adiabatic vessel, right? So in here I filled this up with boiling water about 20 minutes, half an hour ago in my office. And so what I'm going to do is open that up, so it's still reasonably warm. And I'm just going to sit now the heat engine on top. And so now what's going to happen is the hot water, the steam coming off the hot water, is in contact with that bottom plate. That bottom plate is in contact with the gas that's inside. And that's going to start to expand that gas. Okay, so I got a little impatient there and gave it a nudge. So what's happening, right, is as the gas is in contact with the plate at the bottom, which is hot, it expands. As it expands, it pushes the piston upwards. The piston goes upwards. That causes that disc to fall down. When the disc falls down, then the gas is only in contact with the top plate, which is our cold reservoir. And then the gas cools down again, and the disc falls. And the reason, you can see that's stopped now, and the reason that it's stopped is because we need proper thermal reservoirs on both sides. And the bottom is a good thermal reservoir because I've got a big chunk of water in there that's hot. The top one is not really a good thermal reservoir, just because it's sitting there in the air and there's not enough to carry the heat away. So I brought in some ice cubes. And so I'm just going to sit the ice cube on the top there. Okay, so it's doing two things. It is also lowering the temperature of the top plate. But I don't think that's the main thing. I think the main thing is that it'll act as a proper heat reservoir. So I just give that a kick again, so you see that's going. And I ran this in my office for about an hour on that cup of hot water. And I went through 3 ice cubes in the process. So you can see it's really going, right? So like hopefully that kind of brings to life a little bit these heat engines that we've been talking about. Okay, so what I'm going to do then is another phase. I'm going to get rid of this ice cube. And I just want this to sort of come back to room temperature. So I'm just going to sit that there for a second. You can see it's still turning because that bottom plate is still hot and the top plate is still cold. So while ever there's a temperature difference there, it'll drive this engine. And so I've just put some liquid nitrogen in there. And now I've got, this is like I said, it's a bottle cap. Actually, sorry, there's one other thing that I need to do first, which go back to the heat engine. So you can see there now, it's kind of equilibrium point, if you like, is there with the piston down. And so what would happen now, right? Before what we did was we put this on a hot reservoir on the bottom, and the hot reservoir caused the gas to expand, and when that expanded, then it drove the piston up. So what I'm going to do now is to cool down the top plate, and that's going to cause the gas to contract when it's in contact. But you can see this, it's already kind of in that equilibrium point. So what I need to do is to add a bit more gas into our heat engine, because I want it first to be kind of, its expansion stage I want to be the sort of room temperature stage. Right, so what I'm going to do is just open up this seal again so I can pull a little more air in, and I'm just going to drive that piston up to the top, and now I'm going to seal these again, and hopefully what this will do is just adding a little bit more, a little bit more gas into the piston. So now it's happy to be up. Yeah. And so I've sealed that nice and tight. So I'm just going to put this into the liquid nitrogen. Now it boils, as soon as I put that in there it starts boiling, but now I have a little liquid nitrogen inside the bottle cap, and I'm going to put this on here. And you can see, you probably can't hear, but yeah, so you can see that's boiling, right? So it's 77 degrees liquid nitrogen in contact with this top plate, which was at room temperature, and so that liquid nitrogen boils off really quickly. And I'm going to do that a couple more times, maybe once or twice more. And what I'm doing is I'm just cooling down this top plate. Okay, I can see that that's boiling a lot less than it was before. So I guess that's now a pretty cold top plate. And it should run. Yeah. So now it's running again. So now it's the thermal gradient in this case is the bottom plate, which is at room temperature, and the top plate, which is cold. And again, it's going to slow down and stop because the bottom plate is not really a good reservoir, right? But my hand is a pretty good thermal reservoir that is, I guess, at room temperature, a little above room temperature. And so you can see that I can just sort of sit that there. If I touch the top plate, I can feel that it's pretty cold, and it's just operating on the thermal gradient between the top plate and on my hand.